Okay, first example with polynomials, how to deal with a cubic.
How to deal with a cubic?
By graphing.
By graphing. Okay, so we're talking about we're talking about functions with higher degree polynomials, right?
Right.
Okay, so this would be an x cubed graph as its parent function. And so it wants us to describe how to get this graph from an x cubed graph.
X cube's going to have like this kind of a shape.
Yeah.
Or this kind of shape.
So we start with x cubed, and then here's the transformations that are happening. This is from last chapter that we talked about this. We would have this -1 inside.
Super secret opposite society.
Yes, it's inside the parentheses. So it would be right one. I need to remember it mirrors. So
no,
like
it's
this way
right
is
one.
No, it's
yes,
right one.
It's totally to the right
I
one.
watched the video the other one. You need to go right one. That's from their perspective.
Right.
Right one.
Right.
Okay. And then the 2 in front is a vertical stretch.
That's a W.
That's a W.
Then V. Okay, now W in German makes a V sound, so that would have been okay if you would have left it.
We're not in Germany.
Okay, so we're going to have a vertical stretch by a factor of 2,
Yes.
which means that your y coordinate, whatever it originally was, will be times 2.
Yes. Why do I keep thinking 3?
So because it's a cubic equation, so
Okay.
you wrote a 3 there.
Okay, I'm sorry. Not really on my game right now. Okay, so we need to sketch this by hand?
By hand, yes. Stretch by hand.
Sketch by hand.
So,
Looks like a good start.
That's almost a great looking x and y axis there, Mrs. Stevenson.
Okay, so a normal cubic function, you know, at
0.
Hey,
why don't we draw a normal cubic?
Yeah, let's do that. At 0, we're at 0. At 1, we would be at 1. At -1, we would be at -1. And then after that, it starts going pretty crazy because, like, at 2,
8.
So up
Like
here
I can't even
8,
count that high.
with your shoes on.
Yes, with shoes on, I have to actually. If I take my shoes off, I can count right to 8.
So here's a normal cubic function.
Yeah, that's actually really, really good. Much better than I would have been able to do freehand
Well,
style.
thank you.
Yes.
Okay, so we're taking this and we're going to shift it right 1, and we're going to vertically stretch it by 2. So if I take it, I like to do the vertical stretch first because we're multiplying our y values by 2. So at 0, 0, if we multiply our y value by 2, we're still at 0, 0. Then we move right 1, so that brings us right here.
Okay, I can't argue with that.
Okay, at 1, 1, we multiply our y value by 2, and that gives us 1, 2.
3.
And
2,
then
2.
we move right, so that's right here. And so then at -1, -1, multiply your y value by 2, you get down here at -2, move right 1.
-2.
Now after this, because we were already kind of almost off of our graph with the whole 8 situation, I mean, we know what this is going to look like. It's going to look like a cubic function, and it's going to go up really, really fast.
Really, really quickly, actually.
Yeah, because it's even more quick than the original one was, and the original one was pretty quick.
So now we want to
support with a grapher.
Support with a grapher, which we will let you do at home on your own. We will not show you that.
You'll just, right here, just plug this in and see how close you got on your sketch. It should look very similar.
But we can perform a y-intercept.
Oh, right. Compute the y-intercept. So to do that, you plug in a 0 where x is.
Because the x-coordinate for the y-axis is 0.
Right. Absolutely. If I plug in 0 for x, I get -1 inside my parentheses. I cube -1, and that gives me -1.
You keep saying it before I can count it out on my fingers.
Why are you counting when you're multiplying?
Because it's, I don't know.
Hey, we actually did go through -2. Like, that was one of our points.
Which means we did the problem right.
It looks good.
Yeah.